Thanks so much, Kevin, for the warm welcome. We're Joyce and Camden from Amperity. Amperity is a customer data cloud. We unify and centralize customer data for many of the world's largest brands. And today we're going to be talking about how we've built on top of OpenAI's models to help brands make sense of their really complex customer data. We're going to start off today with our friend Lauren, who's a marketer at Acme Retail. We're heading into the holidays. It's a time of the year where brands are really focused on customer retention. And Lauren has a really simple question. She wants to know, how many high-value customers do I have? It turns out, though, this question is deceptively difficult to answer. Why is this actually so hard? There are a couple reasons. The first one is data is really siloed. Acme Retail has a POS system. It has a legacy POS system. It has an e-com system. Each of those systems has different customer IDs. Customers might have used different email addresses, names, physical addresses. It's really hard to even figure out how much a customer has spent at Acme Retail. This is somewhere Amperity could help. However, even once the data is unified, Acme Retail might have hundreds of different database tables. They could have a loyalty database table, a predicted value table, a transaction table. And unless Lauren is actually in this data day in and day out, it could be really hard for her to know where to start. And add on top of that to be able to meaningfully interact with your data, you need to know SQL. To solve this challenge, we built AmpAI. AmpAI is a natural language to SQL tool specifically geared towards non-technical users. It enables brands to build visualizations and also customize the output by encoding their unique rules about their customers. That's somewhere we'll spend a little less time today, but if you want to learn more, please find us after. If we were just building AmpAI for Acme Retail, it actually might not be too hard. Context windows are getting larger and larger. You can imagine we might pull in all of the schema information. We might pull in table samples. We might pull in example questions and results that we've returned. And we might be able to create this pretty easily using relatively naive methods given the increased size of context windows. However, when you take into account that AmpAI has to work for a financial institution who wants to understand who's signing up for home loans, when it needs to work for an airline who's trying to learn more about credit card sign-up trends, when it needs to work for a B2C brand that wants to learn about ad performance, this becomes a really challenging problem. All in all, AmpAI needs to work across hundreds of brands that Amperity serves and more than 5 verticals. The main challenge we encounter here is one of context. In order for AmpAI to answer users' question and create the SQL from natural language, it needs to have information around the database tables, the fields, the values within those fields. And this is really hard when you take into account that there's hundreds of different types of non-standard schema AmpAI must operate over, and also the data could be changing by the day. I'm going to turn things over to Camden to dive into our approach to context management and some of our considerations along the way.
Thanks, Joyce. When we started building AmpAI, we knew we had to be resilient to many different types of schemas across our different brands and verticals. And so we knew that we needed a RAG approach in order to make this work. But instead of using vector DBs or embeddings, what we instead chose to do was add 2 research steps that happen prior to the actual SQL generation step. So we'll be using Lauren's question, how many high-value customers do I have, as a guide to show how we evolved our approach. So the first step we took was sort of a naive approach. We take the user's question in the database schema, and we pass it to a SQL generation step with GPT-4o, and then we pass that to Amperity's internal query engine to run that SQL. But for this specific user's question, how many high-value customers do I have? We're not going to get a great answer because GPT-4o doesn't have the context for what high-value means in the context of your business or your brand. So we knew we needed something more. So our first approach here was to say, take an intermediate step with GPT-4o to rank the top 5 tables and grab the samples of those tables. So this approach takes the user's question and the database schema, passes it to GPT-4o to rank the top 5 tables, and which in this case will include the Customer 360 table and the Unified Loyalty table. Then we pass those to Amperity's internal query engine to get row samples of those tables. And we pass all of that context to the generate and run SQL steps that we had before. But in this case, we're not going to get the right answer. And that's because we want platinum and gold. And in the samples that we have above, we only have bronze and gold as part of the samples that were passed the SQL generation step. So this actually isn't sufficient for us to answer the question. So we knew we needed something more. So we added another research step on top of this, which is to get the distinct values of the most important field. So we passed the user's question in a database schema to another intermediate GPT-4o step that asks it to get the most important field across the entire database schema. This field should be PCLV tier in the table customers 360. Then we pass that to Amperity's internal query engine, which gets the distinct values for all that field and samples them, and then passes that, along with our previous research step, into the generate and run SQL steps. Now that we have both platinum and gold as part of the distinct values that are passed to the final generate and run SQL steps, we have the final answer, which is that predicted customer lifetime value tier should be in gold or platinum. And this is the right answer. So here, as a summary, is our full architecture. We have 2 research steps that we pass the user's question and database schema to. First, to rank the top 5 tables and get the row samples from those tables. Second, to get the most important field and sample distinct values from that field. And then pass all of that context onto the SQL generation step and run that SQL inside of Amperity. Now Joyce will do a demo of how this looks inside of the product.
OK, let's put a UI to a name. We're going to ask AmpAI 2 questions. The first is, how many high-value customers do I have? And then the second is, what products do they tend to buy around holiday? So under the hood here, there are 2 tool calls running, the distinct values tool call and also the tool call to pull the row samples. It's correctly pulled in platinum and gold from the predicted customer lifetime value tier. And we can see there are about 414,000 of these customers. Next, I've asked what the product revenue is. This is challenging because there's actually 10 different product taxonomies that Acme Retail uses. So it's running the row samples tool call under the hood. And we can see that it's correctly pulled in product subcategory. It's a little bit challenging for me to parse these results. So I'm now going to ask another question, which actually invokes another tool call under the hood to graph the results. And soon we'll be able to see that these high-value customers tend to purchase shoes, tops and tees, and jeans around the holiday. It's been absolutely incredible to see the impact that AmpAI has had on our customers and also Amperity's product. The way we understand product usage, or one of the ways, is by looking at the number of queries that customers run over their data in Amperity. Here, the yellow line represents users who are using AmpAI. The blue line represents those who are not. And over the last 3 months, AmpAI has actually led to a 130% increase in the number of queries written in Amperity. So really dramatic impact on our customers. We covered one technical challenge we faced with AmpAI today, which focused on context management and how we feed the right context to GPT-4o. There were many other challenges we encountered as well, around evaluations, around customization. So if you would like to learn more, please find us after. Thank you so much.